Right, hello guys. So this is the second part to adding variables to the compiler. So what we did last time, we added some more token types, we added this extra bit of logic, and we started with this path variable assignment function. So what we're going to do now is keep going with this. So this public pass method is basically what's exposed to the compiler, and this will create our abstract syntax tree. So we're basically going to start by assuming that we're going to have a variable assignment, and if we don't have a variable assignment, then we're going to have a binary expression. So we'll just do return this dot pass binary expression. And then we're returning AST at the end, so that's fine. Now, whilst we're here, this should work fine. This should create like a good tree, but whilst we're here, we'll also add in brackets, which we also mentioned last episode. So this is all fine. So what we're going to do, this pass expression, we're going to put this into pass binary expression. So this is fine, and we're going to give the parent priority equals 0 as well. So we can get rid of this pass expression function now. This dot pass binary expression. So this should all be the same. This is fine. We don't need this return match. So that's fine. And then to handle the to handle the brackets, these are called primary expressions. So basically, a primary expression just can't be like decomposed any further. So this is going to be something like a variable identifier. So if you create if you do let a equal 10, then you do this. This is a primary expression, so we'll handle that here, which brings us back to variable assignments as well. It's also things like parenthesized expressions, any literals, so like strings or just numbers by themselves. So yeah. So we're going to create a function called pass primary expression. And we'll do first token is equal to the current token. Current token, that's fine. And we're going to do a switch case now. So we'll do the key will be first token dot token type. So we basically want to do something depending on what type of token we have. So the first one, which is, if you remember BidMass, it's the bracket. So the first one we're going to want to handle is the open bracket token. So we're going to want to do something in there, and we'll do another case. If we get an unquoted string, so that's when we have a variable access. We're going to want to do that. Let's also do that, and then what else? I think that's fine for now. So let's get default back. Yeah. So the default will just be number token. So we'll just do number token equals this dot match number token, and we'll return that. We can actually just do that like that. That's better. So yeah. So this is sort of the order we want to do. So primary expressions. These are brackets, so parenthesized expressions, and then literals, and then like number literals. So that's sort of the order we're going to handle this in. So for the first case, we're going to consume the bracket token. So we'll do let left token equals this dot next token. We'll consume the operator token as well. Sorry, no, I've said that wrong. This has already consumed the first token. So if the first token is an open bracket, then it's gone. Then we're going to have we'll either have another like parenthesized expression side, or we'll have a binary expression. So that's what we're going to do. So we're going to consume the left token, so that could be like a 1 + 2 or something, and then we'll do the operator token. We'll consume the next token as well, and then let right token, and we're going to match for the close bracket token, and then we're going to return new. So we need to create a new expression type in here. We can just copy. We'll just write it out. So we're going to create a parenthesized expression extends syntax node, and then the constructor is basically the same. So we're going to have we're going to do left bracket expression right bracket, and we'll initialize these. Oops, this dot expression equals expression, not exp. Don't want that. This dot right token, right bracket, sorry, equals right bracket. Fine, that looks okay. Don't think there's anything else. So let's export this. Fine. Okay. So now we're going to return. Where did we do this? Return new parenthesized expression. Hopefully that's all imported automatically. We'll do left token, operator token, and right token. See, make sure I've done all that correctly. Fine, looks okay. And then this unquoted string, so this is going to be a variable access. So what we're going to do is we created this variable access thing. So what we're going to do, we'll do const identifier token equals, we'll consume the token. So this will next token. So we've taken the unquoted string and we're going to return new variable, no, not assignment, we're going to do variable access, and we're going to pass in the identifier token. Actually, we'll pass in the value, token value. And that looks fine. So now we actually need to call this function, and where we're going to do that is this shouldn't actually be, this should be this dot pass primary expression up here. So yeah, so this is like the lowest level, which is, hopefully that makes sense. The rest of this looks fine. Okay, cool. So now what we'll do, we'll move on to the final part. I'm just checking this. I think this is fine. We'll soon find out. So now we need to move on to the final part, which is the evaluator. So there's a lot to change here. First things first, we need some way to keep track of the variables. So we're gonna initialize this dot variables equals something, and what we're gonna do when we construct the evaluator, we're gonna pass in an object called variables. So we'll just do variables like that. Fine. So now what we're going to do, right, so we're going to handle brackets first. So if the AST instance of parenthesized expression, we're going to do something. We'll do AST equals AST dot, I think it's expression is the middle bit, yep. So that's handling brackets, and we're going to handle variable assignments now. So if it's an instance of, so this is variable assignment, and basically we're going to get the value of the variable, and then we're going to store it in this dot variables. So we'll do const value equals this dot evaluate. So we're going to recurse. We're going to get node dot variable. Oh no, not node. Sorry, I'm reading something else. Variable value, and then we're going to put this into this dot variables. Use the square brackets, and we'll do ast dot variable name token value equals value. So hopefully this makes sense. So what we're doing is our AST is going to be this variable assignment object, and basically we want to get the variable value. So we'll recurse through it, get this value, and then access the variables object. We're going to create a new entry with variable name value, and we're going to make it equal to this value we've just gotten here. So hopefully that makes sense. Now we'll handle accesses. So if the AST instance of can't type instance of variable access, we're just basically going to do this dot. Actually, let's check. Here's where we'll do our check to see if the variable exists. So we'll do if this dot variables and then ast dot variable name. So basically, if it's in the variables object, then we're good, and we'll just return this dot variables ast variable name. Otherwise, it's not in there. So we'll throw new evaluator error, and we'll do a nice bit of debugging as well. Error variable. What do we want to do? AST dot variable name is not defined. So if we try to access an unknown variable, then we'll throw this little error, which is good. So then now we're handle binary operations. Now what do we need to change anything here? I don't think we need to change anything there. So we're handling brackets, variable assignments, variable accesses, binary ops, and then it's just like literals down there. Otherwise we throw an error. Okay, that looks fine. So let's give it a go. What's the chance it works first time? So let a equals 10, and it doesn't work. Okay. That should be number, like that. Not number token. Let's try this again. Okay, something in the evaluator now. Oh, hang on a sec. It might help if we pass something into variables. So let's go to main. New compiler. So okay, so we'll do let variables equals object, and then we'll pass that into here. So you also need to change the compiler. Let's save that. So this takes in variables. This dot variables equals variables, and then we need to pass that to here. Variables. Okay, that should work. Let a equal 10. Unsupported syntax node undefined. What does the hell does that mean? Save this. It's fine. Yeah, it's fine. So you can do it. So value. Am I being an idiot here? Oh, it should be returning value. That's what it is. Okay. Right. Let a 10. 10. Okay, cool. Right, let's get rid of this debugging. So that's fine. Just from console.log. We can get rid of this. That we don't need that. Yeah, the rest is fine. Okay, cool. So now if we do this again, so let a equal 10. Looks good. And we're still printing the tokens for some reason. Log. Oh, that's why. I thought I got rid of that. Oh no, I pressed wrong button. Okay, fine. Let a equal 10. And if we do a, then we... it's not defined. I'm pretty sure it is defined. But with this here, let's put the main function. So we're doing compiler. Oh no, that's why. I'm an idiot. Let a equal 10. Hey, there we go. A working. Woo! So we do let a equal 10. Let b equal 20. A plus b. It does in fact equal 30. Come on. And if we try doing let a equal b equals c equals 15, we do a plus b plus c equals 45. Come on. Oh. Yeah. Okay, that's good. Yeah, I can't actually tell you how long that took to like figure out before filming this, recording this episode. Okay, so that's good. So we can do stuff like let I equal 0, and we can do let I equal I plus 1. Okay, maybe we can't. So let I equal 0, we do I. Why is that? That's really strange. We let A equal 0. We let I equal 1. And like a number. That's really strange. So why is that? So let A equal, that's like. Is it because this is we should do not undefined, maybe. So is that gonna work? I equals I plus 1? No, because we need the let. So that worked. So okay, that makes sense. So I found a bug. Let's. To be fair though, I'm pretty happy with that. Okay, so what we'll do is we're on main. So let's do. This is episode 5. Variable. This is 5 and 6. So we will do episode 5. And 6 variables, and we'll add accesses parentheses. I don't know, I'll just do brackets, I can't spell that word. Brackets and bit of tidy up, which is good. So the final part of this episode is adding a couple of tests. So what we're going to do in the end-to-end test, we're going to do should create new variable and reference it. So we've got our compiler here. We're going to pass an empty object here just for the variables to be stored. What we'll do is we'll do assert.strict equal compiler.compile, and we'll do let a equal 5, and it should output 5. It should be like that. And then what we'll do again is we'll do strict equal. So we'll reference that variable now. So compile, we'll call it a, and that should equal 5 again. So let's do node-test, and the end-to-end suite passes, which is good. What other tests do we want to do? Let's also check we can do calculations. So should perform calculations with variables. So these get rid of assert.strict equal. So we'll just do some simple calculations. Compile. Let a equals 25. This should return 25. Assert.strict equal. Compile. Let b equal 10. Should return 10. And then we'll add them together. And that should equal 35, I think. Is that what it is? Yeah. So let's run that. Oops. Oh. Whoops. And it's working. Let's try, let's also, because we've added brackets as well, haven't we? We need to test that. So if we do node main, so if we do 1 plus 2 star 3, alright. Oh, we got a bug. Token type plus token type plus token. So pass this. What have I done wrong here? But it's missing something. Oh, hang on. Yeah, we need to. Okay, yeah, no, I'm being an idiot. So this, the operator token, or it should really be expression token. But no. Okay, this should be. Yeah, so this operator token, if we just call, what's it, next token, this is just gonna, it's just gonna consume the token, and not do anything with it, which isn't very helpful, because if we've got something inside of these brackets, we need to actually figure out what's going on. So if we get 1 plus 2, it's just going to consume that token, not do anything with it, then look for a closed bracket token. So if we call pass variable assignment, then what we'll do, we'll look for any variable assignments within the brackets, we'll look for any binary expressions, any literals, and then we'll keep going. So if we do this now, 1 plus 2 in the brackets still doesn't work. Pause. This looks fine to me. Maybe pass variable assignment. This might bracket token. So it's not a number. This is a number. That's the only. Oh, it's because this is a number. Why is that? 1 plus 2. There we go. Okay. Yeah, on my other screen I've got this named as number token, so that's what it is. Okay, cool. So now if we do 1 plus 2 times 3, that's 9. I'm trying to think off the top of my head. Do something like 2 times 3 plus 4. That's equals to 14. If we didn't have the brackets there, it'd be different answer, which is good because it's doing the order of operations correctly. And then here it's doing the brackets first and then. Excellent. Okay, so let's quickly add some test cases for that as well. Just use this. Put this up here. So should handle precedence with brackets. So we'll just do that same example. So 2 times 3 plus 4, and that should equal was it 14? 2 star 3 plus 4, that should equal 10. Let's do something a bit more nested, so let's do compile 2 times 3 plus 4 minus 1. Let's try it. I'm going to do node test. Oh, it should probably put the arguments in. What's this going to equal? 12. Brilliant. Okay, good. There's something, it's printing these out. I think I've just forgotten to, yeah, I've forgotten to remove that. Cool, okay. So now we've got a pretty pretty good test suite. So we've got all of our Alexa and parser tests. What I might do off camera is add a couple of parser tests just to make sure we're parsing the brackets properly. Make sure I'll also add Lexa tests to make sure we're lexing the tokens properly. But to be fair, most of it's handled in the end-to-end test. If something goes wrong here, then we know we've got a problem. So yeah, thank you very much for watching. Hopefully this hasn't been too boring. It's made a lot of sense. If there's any questions, put them in the comments. I'll try and answer them as quick as possible. For the next episode, I'm thinking we'll have a look at maybe adding for loops and some comparisons. I'm not sure how easy that's going to be because we don't really have a type system, so we're going to go sort of full JavaScript style and do a lot of type coercion. But I think once we've got some comparisons and some for loops, then this language is actually sort of coming together. Like we can actually start to do something quite useful with it. So yeah, maybe we'll add some more operations as well, like using the modulo, maybe the power. But yeah. Anyway, thank you very much for watching. All the code will be on GitHub as well, so I'll push it up now.